So what I want to do today is just, to share some ideas that started to me to grow in my mind, when the lunar landing, people start to talk about lunar landing. We spent actually almost 15 years working on the analysis of the ExoMars landing site. I'm talking about not the scientific analysis of the landing site, but the technical analysis to understand the risk, the hazard, and the possibility of landing on Mars. And of course, we actually worked on something like including the 16 and the 18 or 20 or whatever, we worked on something like, 13 landing site, actually certifying a couple of them, at the end. And so the moon seemed to be quite different, and we start to think, what are the difference between the moon and the Mars? One is that probably the moon is simpler than Mars. Here you see some of the analysis that we did, for this one, okay, that we did, for the certification. This is actually the analysis of the reflectance of the radar, slopes or whatever, and other things, and actually the result at the end is a map of the hazard. There is not only this, but one of the map of the hazard that is actually coming from geotechnical, basically geotechnical maps. Anyway, so the difference with the moon, okay, the moon is simpler, geologically simpler, geotechnically simpler, and also is simpler to be analyzed, But what is really complex, more complex, is actually what we are going to do on the moon. At the end, we are not putting a couple of rovers or even a few humans. We are putting many rovers. We are putting many humans at the end. And even now, the diversity, I was impressed yesterday by the diversity of activities that are around, So actually, the diversity matched by the wish of the exploration that is much more complicated than the Mars one, make the problem, of logistic, of surface operation, the construction of infrastructure and so on, the most important things, So in selecting a landing site and also in actually working on it, we need to take into account the trafficability of the area around, because we are not just landing and just moving a rover for a while, that so far we are going to Mars, we are actually trying to mine some areas. We are trying to explore a larger area to mining prospect or to find, water all around. This is something of extremely more complicated that we need to understand, the risk in doing this kind of operation. So the difference what is, look, we are going in the Arctic, is refreshing, at least, so it's hotter like BL in these days, This is just very simple operation, you just land with a chopper. This is Ellesmere Island in the Canadian archipelago. And if you are 2-3 geologists that want to go there and do some observation, it's very simple. You go there with a chopper, land in the chopper, take your stuff, put a tent, a couple of tents, and then you are going to work. But you can investigate the Arctic even in this way. And this way, is comparable in some way to what we are going to do on the moon. We want to put, this is actually the exploration with the polar stern, you know, is a fantastic icebreaker, German icebreaker. And with the mosaic expedition of a few years ago, this is a polar stern, and you can see that, you know, they downloaded a number of small infrastructure, scientific instrumentation and so on. And this is a cartoon that actually exemplifies something. So if you are actually dealing with the moon at the end, you know, we will have to think, you know, to something like that, not something like the image before. So, and also, I mean, just an example, if you land with a cargo, and then we have to download with material from this cargo, the slope constraint is extremely important, because it's not just the landing of a platform and a rover that has to egress. No, it's actually you have to download things. You need, you know, instrumentation to download. You need to have much more stability. So this is one of the most complicated things that we are actually dealing in the lunar exploration from this point of view. If you really need, you know, at the end, you know, to build some infrastructure, you know, we have to start, you know, since the beginning to understand if the area that we are going to explore is actually suitable for that. Is suitable for operation, for mobility, and for things like this. And this is quite important. Now we move from the Arctic to Antarctica, and I put two hats, the Shackleton hat and the Scott hat, and this is interesting, you know. Scott went there because there was some experience before in that particular place. But this place, you know, and that is actually over here, sorry. Oh, sorry. Usually I'm a big mess, you know, with this stuff. The Scott hat is the one that he used, you know, to start the things. Is somewhere around here, where there is actually a Shackleton hat, and now there is McMurdo, there is a Scott Base from New Zealand, you know. But this was the worst place, you know, to start an expedition, and the result was clear, you know. It was very far from South Pole, and we had to cross glaciers, mountain chains, and many things, you know, many other obstacles, you know. Amundsen, starting from here, was actually a piece of cake, you know, to reach for other reasons as well, you know. So at the beginning, we are going to create actually the base, you know, for the future. So when we want to build, you know, something bigger, for sure we'll be actually influenced by the inheritance, you know, with the first activities. And if you look at the South Pole is not a very a piece of cake, you know, to land over here. It's complex, you know, and we have to take it's simpler, definitely simpler because than Mars. But you know, if you remember, the landing of Apollo 11 was already dramatic. I remember Bob Strom was telling me the story, you know, from this landing. They landed, you know, with just a few fuel available. So we cannot actually underestimate the problem of the landing. And I wanna finish, you know, with something that is very popular now, lava tubes. Everybody talk about lava tubes, and definitely they are a very good place, you know, where to be protected. They're a very good shelter. And I want to show you my favorite lava tubes. Is here. Is this one? Is a null, just a skylight, you know, and the lava tube is below. It's very large. Is in Danakil. The Danakil Depression is one of the worst places to be there. Christian Koeber can tell you, you know, something about that. I don't know what it is. And this is something that I like a lot. I will, to be sincere, I would hate if I am an astronaut to be actually encapsulated within a lava tube. I'm not an astronaut, and I'm going to retire also even quickly. Not from the astronaut, from the university. And to be at the very end, to be underground could be a problem. This is actually Camp Century in Greenland.
Sorry to interrupt, but you need to wrap up.
Oh.
Running out of time.
Camp Century was a military base, even scientific, but mostly military base in northern Greenland, not far from Thule. And this is actually the scheme, vertical scheme. They were going very deep, and then they discovered that ice moved. So they have to abandon, in a few months, the entire structure. So we have to think very carefully when we will land, on the moon, to think to the future. What we want to do to the future. Okay, thank you very much.